Hey everybody, another video on 2.6 algebraic methods. This time around we're looking at all the achieved questions from that 2020 exam. So from the website link, check it out if you haven't already. Question number 25 is where we're going to start off with. And we've been asked to factorize this expression. So let's start by jotting down my expression. So we've got 6x squared plus 13x minus 15. So a few different ways to factorize. I always use something called the grouping method. If you're not sure about this and want to know more about it, maybe comment in the comment section and I'll reply with a link. But our first step is we're going to multiply -6 and -15 together. So that there is going to come to -90. I now need to figure out a pair of numbers that adds to the positive 13 here and multiplies to the -90 over here. And this is a little bit tricky. So normally to help me out, I do my times tables. So I'm going to go 1 times 90. So that definitely gets you to 90, but it doesn't have a difference of 13. That's got a difference of 89. So it's not going to be that. It's going to be 2 times 45. That's got a difference of 43, so it won't be that either. 3 times 30, that's got a difference of 27, so it's not that. 4 doesn't work, and then it's 5 times 18. And I'm going to stop here. 5 times 18, they've got a difference of 13, right? So that'll help me out. So my two numbers that I'm thinking of are going to be -5 and positive 18 because they're going to multiply to the -90 but add to that positive 13 up there. So now my next step, I'm going to split this 13x into two parts, -5x based on the number here and then positive 18. So we're going to write down 6x squared minus 5x plus 18x minus 15. So just noting, this here comes to 13x, which is what we've got up here. So it looks different, but I haven't actually changed the equation, so I can do this. So now the groups, so this here, we'll call it group number 1. This here, we'll call it group number 2 with single bracket factorizing. So I'm just going to write that down there, single bracket factorizing. I'm going to factorize each of these two groups. So these here at the top, or the left-hand side actually, they've only got an x in common. So that's going to be x, and my leftovers will be 6x minus 5. The next group, they've got a 3 in common by the looks of it, so that's going to be plus 3, and that's going to be 6x minus 5. So the point here where we're up to is why I like this method. If you've done it correctly, you're going to have the same bracket twice. If you've stuffed it up a little bit, this method lets you know. It's almost self-checking, which is really nice. So the bracket that comes up twice, I'm going to write down here, 6x minus 5, and my leftovers are going to come together to make the second bracket. So that's going to be x plus 3. And just like that, we've factorized it using the grouping method. We are now on to question number 26 from the website. And basically, we've got this expression and we're looking to convert it to this form here. So another way that this is described as is we're looking to complete the square. So we're looking to complete the square. If this is something that you're not familiar with and want kind of further guidance onto it, usual deal, let me know in the comment section and I'll reply with a resource that's helpful. So I'm going to start by writing down my expression. So fx is equal to x squared plus 10x plus 22. So when I'm completing the square, I always underline this 10 part because this 10 part is the key bit to here. And my first step is I always try to find 1/2 of that. So 1/2 of that is actually just going to be 5, isn't it? And then once I've got that, I'm looking to square whatever number I get. And that there it's 25. So what this bit here means is to complete the square, we need a 25 somewhere in our expression to make the factors work when we factorize. So what I'm going to do now is, so carrying down with my equal sign, I'm going to go x squared plus 10x, and this here is where I'm going to do plus 25. So I need this 25 to make the factorizing work, but in maths we can't just add something on whenever we want it. We've got to always make things balance. So to counteract this plus 25, I'm going to do a minus 25. So by plussing 25, minusing 25, that's 0. I haven't actually changed what we're doing. It still balances, it just looks a little bit different. And then finally, I'm going to add on the 22 at the end. I can now factorize this, and This is here, when you factorize it, you should get the same bracket twice, because what adds to 10 and multiplies to 25? And that's going to be x plus 5 and x plus 5, of course. And this stuff at the end simplifies to minus 3. And because I've got the same bracket twice, that's a square. So I'm going to go x plus 3, or x plus 5 squared, and then I'm going to minus 3. And I've now got it in the perfect square form that the question has asked me. We are now on to question number 27 from the website. So as a single logarithm, simplify this thing over here. So we've got log bracket 9y minus log 4, and that's going to be minus log 3y. So I'm going to go a bit slower here because, again, like the previous video, the log ones are where people tend to struggle. So the first, I've forgotten that plus sign there. So the first thing I'm going to focus on is I'm going to merge together the first two, and then I'll do the third one later on. So because these logs are being added together, you'll see a function on your formula sheet that helps you with this. So just to get us going, so I know that log A plus log B, that's always going to be equal to log AB. So basically what I need to do is I need to multiply the two things in the bracket together, and then I can form that or make that into a single log. So that there is going to be log, and then brackets 36y. Just to clarify, that's the 9 times the 4. And we're then going to take away our log 3y, which we didn't look at all. So the next formula that we're going to look at is similar but a little bit different, but log A minus log B, that there is always equal to log A divided by log B. So we can merge this subtraction together by dividing the term inside our log brackets. So we're going to have log 36y divided by 3y. And here we can simplify the stuff. The y's are going to cancel each other out, and 36 divided by 3 is 12. So all of this mess, when it gets down to it, is going to become log 12. Now on to question number 28. So we've got question 28 here, and we've been asked to solve this question. So a simple one, so let's write it down. Log with the base of x of 36 is equal to 2. So like the previous video, I'm going to use something called, I call the snail method. So we're going to move the x underneath the 2, and that combined is going to be equal to 36. So you can kind of see it looks a bit like a snail. So it's going to become x squared. So that's me moving the 2, or the x underneath the 2. And as I said, that's going to be equal to 36. Now that it looks like this is actually a piece of cake, isn't it? You probably would have done these in year 9. So the opposite, we're going to square root both sides. So x is going to be equal to plus or minus 6. The issue here being is you can't have a negative log. So x is equal to 6 only. And that's because x must be greater than 0. We are now on to question number 25 from the website link. So question, 29, there it is. We've got this expression here, and we've been asked to make x the subject. So just to clarify, when it says make x the subject, that means x is equal to something else. So that means we need the x by itself. So let's start by jotting down the question. So w is equal to x plus 2 to the power of 5, or 2 over 5. So the first step here, this is a bit of a math trick. I'm not sure if your teacher ran you through all of these. But what I'm going to do is this power, I'm going to move it over to the other side here. And the nice thing about that is when I move it over, I've got to do the opposite. And the opposite of to the power of 2 over 5 is the power of 5 over 2. So that means this is going to become w to the power of 5 over 2. So you can see that fraction has been switched around as I move it to the other side. That's going to be equal to x plus 2. And because I want x by itself, I'm going to move this over to the other side. That's going to become a minus 2. So we're going to have w to the power of 5 over 2 minus 2 is equal to x. My final step is normally kind of negative or fractional powers aren't really considered that simplified. So I'm going to switch this over to third form and a little formula to help you remember what to do. So x to the power of a over b is equal to the b root of x to the power of a. So hopefully you can see what I've done there. So the denominator sits inside the square root sign, and a becomes the power of whatever's inside there. So doing that here, so x is going to be equal to, so as I said, my denominator is going to be inside that square root, so it's going to be the square root of w to the power of 5, and then that's going to be minus 2, and we know when there's a 2 sitting there, that's actually invisible, isn't it? So that means x will be equal to the square root of w to the power of 5 minus 2. So that wraps up all of the achieved questions from this 2020 exam. Hopefully you found the video useful. Keep an eye out for the merit and excellence stuff that's going to be coming out shortly.